So now that we've talked about Java virtual threads and Java platform threads conceptually, and I've talked about some of the APIs, let's actually walk through a case study that will illustrate, hopefully very vividly, the difference between these two mechanisms for creating threads. And this particular example is going to demonstrate using either the virtual thread creation mechanisms or the platform thread creation mechanisms, and you'll see the differences between them in terms of performance. And this example, as usual, can be found in my live lessons repository in the Loom project in the ex1 folder. So if you take a look there, you will find the code we are about to walk through. So here we are in the ex1 project in IntelliJ. And if we click on ex1, oops. So here we are in the ex1 folder project in my GitHub repository in the Loom project, and we click on ex1, and we'll see the code we're going to look at. This example will show how to create, start, and use virtual and platform threads that are now available in really modern Java. And in order to run this, you'll need Java 19 or later, and you'll also need to use Gradle 7.6 or later. And that's what comes configured in this project. This particular example is going to generate a very large number of random integers. And then we're going to check to see whether those integers are prime or not. We're going to check the primality of these large random integers. And we're going to use a thread to check, a separate thread to check whether each of these integers is prime. So it's going to be a very large number of integers and a very, very large number of threads. Here's an atomic integer that we're going to use to keep track of the iterations we've done so far. You'll see this is accessed from multiple threads, so we have to make it atomic. And down here, we come in and we parse command line arguments. Here's what the command line arguments look like. If you take a look at the configuration file for this project, you can see a couple things. You can see we enable preview. That tells the Java virtual machine that we want to be able to use Java 19 threads. We then have this command line argument, and you can see that we're going to debug. We're going to create 20 million threads. That's a lot of threads. And every 1 million iterations, we're going to print out some diagnostics so you know the program is still running. And we're going to basically switch between platform or virtual thread. So -p, -t, says make a platform thread, -tv says make a virtual thread. So let's start out by making virtual threads. So we come in, we print out how many test elements we're going to have, in this case 20 million, and that's how many threads we also have. And then we come down here and we generate the random numbers. Here's the random number generator, so we're going to create 20 million random numbers. We're going to do that by saying, make me a new random number generator, make me a stream of large random integers up to count of them, or count of them, which is 20 million, and make them within this range. So they're going to be really large, up to the maximum value that we have here, which is, I think, a very large value. Convert each primitive int to an integer, and then make that a list. So we have a list of randomly generated integers using some cool Java streams mechanisms. You can see it goes up to max value of integers, so it's a very large value. Then we're going to go ahead and start the test. And we're going to either do virtual threads or we're going to do platform threads, depending on what parameter we set on the command line. So let's go take a look at start threads. So what start threads does is it creates a stream of integers, of ints, from 1 to the number of elements, so 1 to 20 million in this case. So we have 20 million of these things, and then we print a little helpful diagnostic periodically. So every 1 million iterations, we're going to go ahead and we're going to print out the number of threads that have been started at that point. You'll see what that looks like when we run the program. Here's the real meat of this method. We call map to obj, which takes this stream of integers and turns them into a stream of objects. And the objects that are going to be created are going to be thread objects. So we're ultimately going to end up creating a list of threads. You can see a list of threads. We're going to make it a list of threads. And this method here called makeThread is going to make the appropriate type of thread, either a platform thread or a virtual thread. And we're going to pass it a runnable and a flag that indicates whether it should make a virtual or a platform thread. So the runnable we're going to pass is going to take the ith -1 random integer in this giant array, and it's going to call this method makeRunnable. And you can see what that does is it returns a runnable, And the runnable, when run in the thread, is going to check to see if that particular integer is prime or not. And if whatever the result is, if it's the right iteration, in other words, every 1 million iterations, we're going to print out whether or not it was prime or not prime. And if it's not prime, we give it smallest factor. So that's what the computation does that we return, just to do some interesting things that take a while to run. And here's make thread. So what make thread does is it's a factory method that takes that runnable we just made, takes the virtual, takes a Boolean that says, should I make a virtual thread or not? If we're told to make a virtual thread, we say thread.ofVirtual unstarted, and we give it the runnable. So we make a virtual thread that's not yet started, but it'll run the runnable when it starts. Otherwise, if virtual is false, we make a platform thread that's unstarted and give it the runnable to run. OK, so that's kind of where we get our list of threads, either virtual or platform. And then we just go ahead and use the for each terminal operation. It's actually really just the for each operation on a iterable. And we say for each of the threads, start the thread. That's what's called a method reference. We say start the thread. All 20 million of those threads will start up at that point. And then for each thread that is running, we're going to join with that thread. That basically says wait until the thread is done. So we're going to wait till all 20 million threads finish. And we do a little clever exception laundering here to convert the checked exception method, thread join, which is a kind of a goofy checked exception, which is ugly and difficult to deal with. We convert that to be a runtime exception so we can use it in the for each method. So that's basically the code. So let's go ahead and run this code and get the results. So here's the program. We start running it. We compile it. And as soon as it compiles, it'll start running. And you'll see when it starts to run, it's going to create those 20 million thread objects without starting them. And then it's going to go ahead and start them. So you can see every 1 million iterations, it says how many threads were started, or really should be created. And then you can see now these are running in virtual threads. You can see the virtual thread ID. It's a virtual thread. It's running atop of something in the fork join pool. That's the so-called carrier thread. And it's printing out whether the numbers that it's checking are prime or not prime. You can see that's the result. And the thing to notice here, it took about 36 seconds to do all of that. OK, great. So 20 million threads in about 40 seconds. Pretty darn good. Now let's turn around and run this, changing the thread type from virtual to platform. And you see I just changed the command line argument. And now it's going ahead and it's making 20 million platform threads. Now you can see that when we create the threads, it's still going pretty fast because we haven't started them up yet. We haven't called the start method. We're just creating threads. So we've got 20 million platform threads. That really isn't the thing that's going to take a long time because it's just making an object. It hasn't created any resources. Now, once we get to the end of this sort of beginning part, now we're starting to do the processing. And I'm not going to let this run for very long because it'll take forever if it will ever finish. But what's happening is we've now got 20 million threads started on my poor computer. And my computer has a lot of horsepower. It's got 10 cores. It's got the Apple Max 1 Pro. It's got 64 gigabytes of memory. And it's just crawling along because we made 20 million platform threads. And I probably should shut this thing down because otherwise it'll crash my machine at some point. But you can see it's not running anywhere near as quickly as the virtual threads mechanism, which took 40 seconds to get through the whole thing. And it's probably been about 40 seconds, and we haven't even gotten done with the second million bunch of threads. So let's mercifully shut this thing down. And the key point I want you to come away with from this is that virtual threads are much, much less resource consumptive, and therefore you can have oodles of them without causing your machine to come to a screeching halt.